Okay, so we've got our pawn set up and we're ready to give it some functionality. Now, in Unreal Engine, it's pretty easy to create a designated user input, meaning keyboard stroke or mouse click, and map that to a C++ function in Visual Studio. So to do that, what we do is we go to Edit and click Project Settings. And in the project settings, we can scroll down here until we find Input. And in input, we have action mappings and axis mappings. Now, these are two different types of ways to map input to functionality. Action mapping is like a one-off thing. As soon as it gets fired, it happens and that's it. And it's usually with, things like key presses, and you can map an action to when a key is pressed down, and then also when the key is unpressed or pressed up, and those are just one-off functions that get called when those events happen. Now the axis is more of a continuous thing. When you have a key press mapped to an axis, it's constantly being called, kind of like the tick function, and as long as the key is not being pressed, the value is going to be 0 returned. It's like a function that returns a float value. It'll return 0 unless the key is pressed, then it'll return 1. And this axis is nice because between 0 and 1, you've got all these values that you can have, and that allows you to do things like have touch sensitivity with a controller thumbstick or things like that. When you have a thumbstick that has varying levels of sensitivity, you can get different values between 0 and 1 or -1 based on those axes. So for our purposes, we're going to create axis mappings, and we're going to click the plus sign and click the drop down, and you'll see new axis mapping. So we get to actually name these. And I'm going to name the first one move forward. And you'll see as I name it, you get this other drop down, and this is expecting you to specify what keys or what types of input you're going to use. For now, we're going to use the keyboard. So we're going to click the drop down for keyboard, and I'm going to click on the up key. So this will happen with the up key, and we can also bind this event to multiple keys. So we can add another one, and we can choose keyboard, and we can use the W key, and we can just keep going. So I'm going to hit this plus 2 more times, and I'm going to also map the keyboard S key and the keyboard down key. And here you'll see scale, and this scales the value returned by this input event by whatever you put in this little text box here. And for S and down, I'm going to put -1. And we'll see in a minute what the significance of these values is, but it's basically what's returned by this event to your function that we're going to later bind to this event, and that function can use this for functionality in the world. And so I've used 4 keys to bind to a single axis mapping. And if I click the plus next to axis mapping again, I can create another one, and we're going to call this move right. Now notice, instead of move forward and move backward, I just had a single move forward and mapped the backward keys to it, scaling the value by -1. We're going to do the same thing with move right as well. So I'm going to say, I'm going to click keyboard and use the right key, and then I'm going to click plus and add another keyboard, and this time we're going to use the D key. And then we'll click plus again, and we'll choose the keyboard A key. This will be going left. So because we're going left, we're going to want to scale this value to -1. And one more time, we're going to use the left key. And again, we're going to scale this value by -1. Now, again, we're going to see exactly how this value here is used by these axis mappings. But for now, just know that setting these up here in project settings means that now whenever these keys are pressed, something behind the scenes is going to happen, and we're going to figure out how to harness that, how to use it. you don't click save anywhere in the project settings. You just change them and they're automatically saved. So click close. And now we're going to go back to C++. So as we go to C++, here in the critter.cpp file, we're going to go down to setup player input component. This is where the binding happens. Now, we have this player input component here that is passed into this function. Now, we're not calling this function. In fact, the calling is abstracted away where we can't see it. All we know, though, is that this function is going to get called at some point, and in this function, we're going to customize those key bindings that we specified in an Unreal Engine just now. So what we do is we take this input component of type input component. It's called player input component, and there's a function that it has called bind axis. Now you'll see that bind axis has some input parameters. Let's see, did I spell this right? Copy this, paste it. Yeah, it looks like it's spelled right. And it says pointer to incomplete class, so we're going to need to include input component. So I'm going to use my favorite way to find out where the header is, and I'm going to type input component.h here. And allow it to find input component. So we'll scroll down until we see it. Here it is, and it's in classes components, so we only need components and input component. So we'll go up here and include that. And we'll include components / input component .h. Okay, so we'll come back down to where we were. Oh, that is not where we're supposed to be. We are not in critter.cpp anymore. I actually had accidentally opened up a file. It's asking if I want to save that file. I'm going to say no. So if you find yourself in a strange file like that, don't ever save your changes if you didn't know what you were doing. And so what I'm going to do is come up here, and we're in critter.cpp now, and I'm going to include components / input component.h. Okay, so now it knows what the player input component is, and now we can use the bind axis. Here it is, and now we get some, it shows you that there's a couple overloads if we click up and down. And what it does is, if we look at the second overload here, it says it first expects a fname, and it's the axis name that it expects. And the axis name was what we created when we set them up here in the project settings. So let's go back and take a look at what we used. And we have two of them. One is move forward and one is move right. So we're going to use move forward and move right, and these are strings. And typically with strings, you're going to use the text macro, text, and it's going to be move forward, and the next one will be move right. So now we'll see that the next one is uObject, and this one is basically what is the object that is doing all this, and we're going to use this because it's this pawn. Now here it's asking for a function, and it's specifically asking for what's equivalent to a function pointer. Now we can give a address to a function specifically by fully qualifying the name of a function, but we don't have a function yet. So what we're going to do is create one. So let's go back to critter.h, and right here in just under this public section, we're going to create a private section, and we're going to create a void function called move forward, no relation to the input axis name, and it's going to have a float, and we'll have a value there. Let's just call this value, and we'll copy this, and just beneath it we'll make a move right and float value for that one as well. So we'll go back, and just under setup player input component we'll create these functions. So void, and we're gonna use a critter, and we have move forward. It takes a float called value, and just underneath here we will paste and change this to move right. So now we've created two basically empty functions, and so the next parameter in this bind axis is sort of a pointer to a function. It's going to be the address of this function. So if you didn't know, you can actually take a function name without the parentheses and use it sort of like a function pointer. You can take the function, take the address of it, pass it in, and now this bind axis function takes a function as one of its input parameters, and it will bind it to that move forward event for the inputs. So when we hit the W or the up key, it's going to call this function, and what it's going to feed into the function for value is the axis, and the axis value depends on whether the key is pressed or the key is not pressed. And when the S and the down keys get pressed, it's going to call move forward, and it's going to send the value scaled by -1. So it'll basically be a negative value, so we don't need to create a move backward function. Okay, so we've established that when we press the W and the up keys, the move forward event gets called, which calls this function, and we got this move forward function that we can then use to move our pawn. Now we're going to need to do the same thing for our other axis mapping, and we called this one move right, and we're going to bind this to the move right function. Okay, so how are we going to move the critter object forward, right, left, and backward? Well, what I'm going to do is I'm going to create a f vector called current velocity. Now this vector is going to be initialized to 0 in the constructor. So we're going to say it equals f vector. We're going to use the f vector constructor with 0.f. And what we also want is a max speed. So we've got float max speed. And I'm going to initialize this one to say 100.f. Okay, so how are we going to do this? Well, in move forward, what I'd like to do is I'd like to change our current velocity, and then in the tick function we'll use that velocity to change our location. So we're going to say in move forward current velocity, and we're going to say dot y, we'll say equals, and I'm going to use the value here returned, and just in case, it should be somewhere between -1 and 1, but just in case it's not, just to ensure that I have control over it, I'm going to use fmath clamp. Now what clamp does is it takes a value, and it takes a minimum, and it takes a maximum, and what it'll do with those minimum and maximums is it'll take this value, it will ensure that it never goes below the minimum, and it will never go above the maximum. So if value itself were say 0.5, clamp won't really do anything to it, but if it were say 10, it will clamp it down to 1. So as long as it's between -1 and 1, it will be unaffected. But if it goes outside those bounds, it will clamp to these boundaries. And so that will ensure that this value will not be scaled above -1 and 1. So if we're setting velocity to something between -1 and 1, it's not going to be really noticeable. So we're going to multiply this by a bigger number, and that big number is going to be max speed. Okay, so this will set our y velocity, and we're going to copy this and put it in move right and use this for the x axis of current velocity, and this one will just take the value from the other event, which is the move right event. So now key presses will result in these being called, and these will update current velocity sort of like every frame, like the tick function. But all this does is alter this f vector. It doesn't really alter our position at all. So what we're going to do is we're going to go here into the tick function and use current velocity. How are we going to do it? Well, let's create a f vector called new location, and let's set it equal to the current location, so get actor location. And we're going to add to this a particular value, and the value is going to be current velocity. And the current velocity is a value, and the definition of value, the units of velocity are some distance per time. And so for some distance per time, we're going to need to multiply by delta time. And that way, delta time, whatever the time is between now and the last frame, will be multiplied by current velocity. And current velocity will be around on the scale of max speed, so like at maximum it'll be 100. And we can't really move something 100 units per frame, that's kind of too much, but 100, say, units per second would be multiplied by delta time to get that 100 units per second result. Okay, so we have a new location. So now in tick, all we have to do is set actor location to new location. And that should do it. So let's go ahead and come back up and we'll build this, give it a second to compile, and then we'll go back into Unreal Engine. Okay, compilation is done. We'll go back into the engine and hit play. And when I hit play, don't forget to click into the viewport, and you can hit the keys and you'll see that they have the effect of moving the pawn. Now, one problem that I'm noticing right off the bat is when I hit W, it's making the pawn go to the right, and when I hit S, it's making the pawn go to the left. So move up and down seems to be moving the pawn in the wrong direction, and going pressing A or left makes it go down, and pressing D or right makes it go up. So that also is a problem. So when we hit W, we want it to go forward instead of right, and this is basically a problem of the limited nature of our pawn. So let's see about fixing this problem. So we'll go back, we'll take a look at move forward, and move forward sets the current velocity Y. Let's try setting the current velocity X, and in move right we'll set current velocity Y, and we'll go ahead and build this. So that's one quick fix to this. Also, if we take a look at our viewport here, we'll see that our forward direction, it looks like if our camera is back here and we look at our little axes here, it looks like that it's in the negative X direction, and so going forward we're going to probably want to go in the X direction. So that should fix it. Let's go ahead and click play, click in the viewport, and now it seems to do what we're wanting it to do. Let's go ahead and hit escape, and we can go back. And if you're not satisfied with the max speed, we can make this actually editable in Blueprints. And so if we copy that, take it out of the private, put it in the public section, then we can give it an edit anywhere. And so we can copy this, give it edit anywhere, and let's give this a category of pawn movement. Build that, and this way we can go back into Unreal Engine and we can take a look at the Critter BP, and we can look at the pawn movement as soon as it compiles. Let's make sure this compiles first. Okay, we have compilation, and we will come back to Critter BP, come back to pawn, and we have our pawn movement here and max speed. So we can take this and we can scale it up, say to 400, compile that, and if we hit play, click in our viewport, we'll see that we're quite a bit more mobile. Now, of course, we haven't set up any collision for this pawn, and we can pass through objects, and it appears that we have collision for some objects, and I think this shape here may be set to ignore pawns. I'm not sure, but it actually does appear that we have collision with some objects. So this is the beginning of a working character. Now, this is very basic functionality. We don't have the ability to turn and look around. The camera's sort of fixed, and it just kind of follows along as our pawn moves around in the world. So there are some games like that, but you may want more freedom, and we definitely have the capabilities of doing that in Unreal Engine. So we're going to get into how to get the camera able to rotate around the pawn, and so that the pawn can look around in the world and see different things, and also maybe include some sort of jump functionality and things like that. So we'll do that in some future videos. So hang tight and get ready for some more interesting stuff.